Good day, I am Chester Ricardo and today we are going to talk about the chemistry of the atmosphere. Learning objectives. Describe the region's temperature profile, pressure profile, and chemical composition of the Earth's atmosphere. Differentiate photodissociation and photoionization processes in the upper atmosphere. And lastly, explain the effects of human activities to air quality, acid rain, and global warming. The Earth's atmosphere. The atmosphere is very essential to the planet. If it weren't for this, life is not possible to survive on Earth. The atmosphere serves as a shield to the Earth, protecting it from radiation and heat. It also protects the air we breathe from contamination with elements outside Earth. Atmosphere's components. Oxygen is essential for life on Earth, but it's not the only component of the atmosphere. The Earth's atmosphere is composed of approximately 78% nitrogen, 21% oxygen, 0.04% carbon dioxide, as well as traces of helium, methane, ozone, and hydrogen, as well as water vapor. The remaining percentage consists of other gases known and unknown to us. Atmosphere's layers. The Earth's atmosphere has five main layers from lowest to highest: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. These layers are separated by temperature, and as the layers get higher, the atmosphere gets thinner until the gases dissipate into outer space. As altitude increases, the air pressure drops. At sea level, the atmosphere is dense, with an air pressure of approximately 1 kilogram per square meter. The air pressure is 10 pounds per square inch at 10,000 feet, which indicates the atmosphere's gas molecules are less dense. Even if there is evidence of microbial life at a high altitude in clouds, this makes it more difficult for a person to breathe and obtain enough oxygen to survive. Troposphere, inner layer, most dense. Most of Earth's weather is found here. This is the most dense among all layers. This also contains most of oxygen we need to survive. Near the surface of the Earth, the global average temperature is 59 degrees Fahrenheit or 15 degrees Celsius. At the uppermost boundary of the troposphere, the air reaches nearly negative 76 degrees Fahrenheit or negative 60 degrees Celsius. Stratosphere, second layer, protects Earth from UV. The ozone layer is found in this layer of the atmosphere. Basically, this is the layer that protects the Earth from ultraviolet radiation. The temperature in the stratosphere ranges from negative 60 degrees Fahrenheit or negative 51 degrees Celsius at the troposphere boundary to negative 5 degrees Fahrenheit or negative 15 degrees Celsius at the top. The temperature increase is due to the ozone layer that absorbs ultraviolet light from solar radiation. Mesosphere. Third layer contains most gases. If you ever see a meteor shower, those gas components are the ones responsible for this. As an external object such as a meteor enters the Earth, it can pass through the outer layers as they don't have as much protection as this layer. The gases create friction, which causes these external objects to produce heat and break apart. The temperature ranges from negative 5 degrees Fahrenheit or negative 15 degrees Celsius at the stratosphere boundary to negative 184 degrees Fahrenheit or negative 120 degrees Celsius at the upper boundary. Thermosphere, fourth layer, where satellites hover. Even though its name suggests that this layer is hot, thermo means heat. This layer is not that hot at all. The reason for this is because there are not enough gas molecules to transfer the heat to the body. In this layer, the satellites hover to document most of the phenomena happening on Earth. The temperature ranges from negative 184 degrees Fahrenheit at the mesosphere's upper boundary to 3,600 degrees Fahrenheit or 2,000 degrees Celsius near the upper boundary as ultraviolet and X-ray radiation from the sun is absorbed. Exosphere, outer layer separates Earth from space. the outermost layer of the atmosphere which separates the Earth from space. The layer is very cold with no air to breathe in. The temperature range from the exosphere can reach up to 2700 degrees Fahrenheit or 1500 degrees Celsius in the uppermost atmosphere as the thin air transmits little heat. Photodissociation and photoionization. Photodissociation. Physical process in which a chemical compound is broken down due to the action of photons. It may be described as the interaction of a single target molecule with one or more protons. Additionally, this method is not restricted to visible light. This implies that every photon with enough energy to impact a chemical compound's chemical bond is capable of photodissociation. Additionally, a photon's energy and EMR or electronic medical record wavelength have an inverse relationship. Therefore, photodissociation processes can include EMR with high energy or tiny wavelength. Photoionization. Photoionization is a physical process where an ion forms via the reaction between a photon and an atom or a molecule. However, we cannot categorize all the interactions between photons and atoms or molecules as photoionization because some interaction from non-ionized species. Therefore, we have to relate an interaction to the photoionization cross-section of the chemical species. Also, this photoionization cross-section depends on the energy of the photon and the properties of chemical species undergoing the process. Differences. Photodissociation and photoionization are physical processes. The key difference between photodissociation and photoionization is that photodissociation is the breakdown of a chemical compound due to the activity of photons, whereas photoionization is the interaction between photons and atoms or molecules in a sample to form ionic species. As the world embraces modernity and industrialization, we tend to produce more greenhouse gases than we know. Over the years, it has been concluded that humans are responsible for the major damages of the Earth's atmosphere. Although there are natural greenhouse gases in the atmosphere such as water vapors and carbon dioxide, it seems like humans are contributing more into this, causing the heat to trap in the Earth's protective layer. The three largest greenhouse gases are carbon dioxide, methane, and nitrous oxide. Once these gases add to the atmosphere, it prevents the atmosphere to release the excess heat, as it is supposed to do. Instead, the atmosphere absorbs heat more as the shield is being thinned by these gases. These elements, when burned, produce carbon dioxide. In 2020, approximately 70% of all the energy used in the United States will be made up of fossil fuels. Some everyday activities humans do that are unconsciously affecting the atmosphere negatively. The reason for this is because fossil fuels are used as well to light up our homes and to keep us warm. This may be a tiny amount of contribution, but if we add this up, it can stretch up to 3.7% of the global greenhouse gas emissions, or 1.4 billion tons per year. Planes, trains, and automobiles. Over the years, we relied to burning fossil fuels such as coals, oils, and natural gases, keeping the lights on. Every email we send, every movie and series we watch, and every time we surf the internet, we add up to the carbon dioxide being sent to the atmosphere. Deforestation. We all know that trees plays a huge part in keeping us alive. Trees absorb the carbon dioxide we breathe out and are produced by cars and factories. A mature tree can absorb up to 46 pounds of carbon dioxide in a year. When these trees are cut down, the carbon dioxide they absorb will be released back to the atmosphere. Over the years, since 1990, the global forest shrunk approximately 200 million acres. In 2011, 61 countries pledged and signed an agreement to restore 420 million acres of degraded forests by 2030. Increased livestock farming. Livestock has been a necessity for food over the years, but humans are not aware of how farming of these livestock contributes to global warming. Livestock, especially cows and sheep, produce methane when they digest food. A single cow can produce at least 220 pounds of methane each year. Even though methane has a shorter lifespan than carbon dioxide, it contributes more to the damage causing the warming of the earth. In 2050, it is estimated for the greenhouse gas emissions to increase at least 60% due to food production. Use of chemical fertilizers. Although fertilizers that contain nitrogen equals more crops, the downside is it contributes to global warming. Fertilizers such produce nitrous oxide, which can harm the planet or warm the planet 300 times more than carbon dioxide. The use of F gases. They are still greenhouse gases even though they don't contribute much to the thinning of the ozone layer. What is F gas? This consists of hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. Nitrogen trifluoride is commonly used in the manufacturing of LED light bulbs. The hydrofluorocarbon are used to power refrigerators, air conditioners, and to make aerosol sprays. Perfluorocarbons are used to make cosmetics, electronics, and some pharmaceutical needs. And sulfur hexafluoride are used as an insulating gas. That is all. Thank you.